The next lesson deals with units, and there's something you're going to have to memorize, and that is those metric prefixes on your in your agenda on page R10. It's all about the, for instance, the centimeters, the kilometers. You're just going to have to know there's this little thing that says milli means 1,000, centi means 100th, and deci means 1/10. You're going to want to know those different prefixes there. Now, the other thing you have to know is that we measure length in metric meters, we measure volume in liters, and measure unit is kilogram. That's a little bit different. You would think that the standard unit for mass would be a gram, but in physics, it's actually the standard is a kilogram. So we'll get into this a little bit later on. But the reason why we use those different things is because they're interchangeable, unlike the English system. For instance, if you had a milliliter of water, that would fill a box that was 1 cubic, I know we can't draw a box, but anyway, you get the general gist of what this, that's supposed to be a cubic centimeter box. It looks like it's falling down, but anyway, that cubic centimeter box there would hold 1 milliliter of water. And if anybody's wanting to become a doctor, we call that a cubic centimeter. Doctors call it a cc. So when you fill up a syringe with medicine and you get a cc, you're actually getting a cubic centimeter or a milliliter of medicine. And if you have 1 cubic centimeter of water or a milliliter of water, it weighs 1 gram. So all these things sort of fit nicely when dealing with water, and that's where the metric system actually really makes sense. Up here, if you had a liter of water, it would weigh a kilogram. Now, it's not a cubic meter, though. A liter is actually a cubic decimeter, and it weighs a kilogram. So we now have to know how to add all these units together. And when you're adding or subtracting units, the units have to be identical. So for instance, 1 centimeter plus 1 centimeter would equal 2 centimeters. And you just bring that over, the centimeters over when you're adding. Now, if you notice here, I have a centimeter, which would be something like that. That would be about a centimeter long. And I'm going to add that to a square centimeter. Well, this would be about a square centimeter, right? Well, those are impossible to add. I don't know what that would even look like. So therefore, you cannot do a linear quantity plus a square quantity, and it just doesn't give you anything. Now, you can multiply them, though. So if you multiply units, you simply add the exponents. So I could take a cubic centimeter and multiply that by a square centimeter, because if you multiply it, you're actually going to put it in a different dimension. Like you've heard like a 3-dimensional object, so this would be 2 dimensions, that square. If I multiply it, I'd be putting it into a different dimension. So I would now end up having 9 cubic centimeters. So here's what I did. I took the 3 times the 3, that gave me the 9. Now this little centimeter here actually has an exponent of 1, and it tells me to add the exponents. So the exponent of 1 plus the other exponent of 2 gives you 3. And 9 centimeters to the 3rd power is the same thing as saying 9 cubic centimeters. Now when you divide exponents, or I'm sorry, when you divide units, you simply subtract the exponents. So if I had 9 cubic centimeters and I divided it by 3, it's supposed to be a division sign there, everybody. It's supposed to be a division sign. I divided it by 3 square centimeters. 9 divided by 3 is 3. And then you subtract the exponents. So 3 minus 2 is 1. So it would be the same thing as saying 3 centimeters to the 1st power. But anything that's to the 1st power, you can just leave like it is. So it's 3 centimeters. So when you divide units, you subtract the exponents. When you multiply units, you add the exponents. Now, what if you had to divide unlike units? Like up here, when you add it and subtract it, they had to be identical. Well, when you can divide unlike units all you want. So if I had 9 grams divided by 3 cubic centimeters, this is actually how we get density, mass divided by volume. 9 divided by 3 will give you 3. And then all you do is put the units over top each other. So since the units are unlike, grams, and you bring the slash down, which means divide it by cubic centimeters. So the way you would read this is 3 grams per cubic centimeter. Now, if you're multiplying, I don't have that on here, but if you're multiplying and the units are unlike, so let's just say I had 9 newtons times 2 seconds. This is a quantity called impulse or momentum. Well, 9 times 2 gives you 18. And then all you do is stick the units right next to each other. So it'd be newtons dot seconds. Newton seconds. Now that doesn't mean Newton per second. Newton per seconds would be written like this. Newtons over seconds. It's a Newton per second. So Newton dot seconds means that the two quantities are multiplied to each other.